Random sample of 100 gave a mean of 52.4 and a standard deviation of 14.3. Is there evidence to suggest that the true mean is different from the assumed mean at the 5% level of significance? This is test. Be honest, and 5% level of significance basically means what? 95% confidence interval. Okay. So I'm going to show you maybe one or two different ways to do this. You can do it more than one way, okay? But I'm going to go for the confidence interval, or I can go for the z-score. Depends on what I want. All right. I'll try I'll use the z-score way first, okay? Now, what did we say earlier about the z-score? That if you're smaller than 1.96 and you're bigger than what? You're considered in the critical region, which means you can reject the null hypothesis. Now, what is the null hypothesis? The mean mu is 50. What's H1 then? Yeah, the mean mu, and this goes for a lot of marks, and it's not hard, it's not 50. You okay with that? Pick your methods. I'll start with a z-score. Okay with you guys? I'll do a z-score. It doesn't tell me what method to use. Would you agree with that? It doesn't tell me what method to use, so I'll start with a z-score. So what do you think for the z-score? X bar take away mu. Why am I using X bar and not X? Because there's more than one. So I'd have a choice of these two options, okay, in the leaving cert. And I'd have to know that I'm picking the option on the left and not the option on the right. And most of you said it a second ago. It's because I took a sample. You get what I'm saying? I took more than one. So it's a sample, not an individual score. So that's why I'm using this formula on the left. Okay. Next thing, what are the scores? We got a score of 52 point. Now, is 52.4 far enough away from 50 to make us doubt their claim? That's what we're trying to figure out. Okay, let's find out. 52.4. Okay, they're claiming it's 50. So they're claiming mu is 50. Then it's divided by the standard deviation, which is 14.3. We actually measured 100 people. It was 100 different, the sample size was 100. So if we go back up here, the sample size was definitely 100, okay? And what can we say about this z-score? Anybody know what the z-score is? 1.678. So 1.68. Now, 1.68 is in what region? Is it in the red region or the safe blue region? Blue region. You got that? So what we can say is that z-score of 1.68 is smaller than 1.96. So it isn't far enough away to reject the claim. Do you get what I'm saying? We have to keep the claim exactly the same. Okay, so the test statistic or the z-score is not in the critical region. And hence we accept the null hypothesis that the mean is 50. Is that okay with you guys? Theory. The machine is serviced and samples taken in to investigate. You're investigating whether the mean length has changed. So what I think we're going to do here is we're going to say that H0 is the mean length has not changed, or it's still, or you can say the mean length is still 210. Okay, and then what's the other one? The mean length has changed, or the mean length is not 210. No, it's null hypothesis means nothing has changed. Okay. Uh, okay. Work out the test statistic. Okay. Will everybody try Z for this? Z equals X bar, take away mu, divided by sigma over root n. A Z score of, now, what's X bar? X bar is the mean of the sample we took. What's the mean of the sample we took? 211.5. Because we took a sample of 100 rods and that's what we got. Now, the population mean would be your original mean, 210. Your standard deviation is 6. Yeah, 6 over, no, wasn't trusting something else. Okay, put that into your calculator, what you get? That score is 2.5. Now, 2.5, set score of 2.5 is bigger than 1.96. This means it's in the critical region. Okay, and here's what we're going to do next. Okay, we're going to just write down the form we're writing at the end here. Okay. Okay, guys, so here's what they want us to write down, okay? Have it here, okay? So, since Z equals 2.5 is in the critical region, lads, you need to take down this writing at the end. It goes for marks. You'll see it in the marking scheme. Yep. Uh, say we reject the null hypothesis and accept the alternative hypothesis. Now, what is the alternative hypothesis again? That the mean has changed. Is that okay? Okay. Now, I'm going to move us on to. Okay, guys. Experience shows that the scores obtained in a particular test are normally distributed with mean score 70 and a standard deviation of 6. When the test is taken by a random sample of 36 students, the mean is 68.5. Calculate the sample statistic for the sample. Okay. Now, a sample statistic is usually a Z score. Okay. So the first thing we're going to do, when you see the word sample statistic, we're going for a Z score. Okay. So question 1, Z score time. So what do you think? Yeah. And what numbers should I put in for each one? What's X bar? 68.5. The claim is the original one. They're claiming that. What? They're claiming 70, aren't they? Okay. And we're going to use the 6 for the standard deviation. It's the only standard deviation there, so it's the only one we can use. 36 students, square root of 36, yeah. Who got minus 1.5? Straight away, we know that minus 1.5 is not smaller than minus 1.96. We know we're in the safe region here. Okay. Now, question 2 is the p-value. Okay. Now, here's how we're going to do the p-value. The p-value is basically, what I'm going to do is, I'm going to say minus 1.5 here. I'm going to say 1.5 here. Vice versa. If my answer was plus 1.5, I'd still use 1.5 and minus 1.5. If my answer was 2, I'd use 2 and minus 2. If my answer was minus 2, I'd still use minus 2 and 2. Now, what I'm after is I'm after the area of these two regions. Now, because I know this is in the safe region, I'm expecting when I add these two green areas together, I'm expecting it to be bigger than 5%. Because it's not in the critical region, it's in the normal region, right? So, can everybody get a set score of 1.5 for me and tell me what it is? Was it? Okay, so this blue region here is 0.9332. Okay, can anybody now tell me what the green region is on the right hand side? 0.0668? 0.0668, yeah? It's not 66? Oh, yeah, you're right. Guys, double that value for me. 0.1336. Now, because that's smaller because that's bigger than 5%. Because that's bigger than 5%, we're in the safe region. Is that right? Now, I'm going to have to. Part 3. Use the p-value you have found to investigate the mean score of the sample differs from the mean score of the population at the 5% level of significance. Okay? So what we say is, it's quite an easy one to do. Okay? It doesn't say use a hypothesis test, so I think we're good without using H0 and H1. But what we're going to do is this. Okay? What we're going to say is since the p-value is greater than 0.05, and so because the p-value is greater than 0.05, oh yeah, we accept H0. So if there was a hypothesis, we accept that nothing has changed. Would you agree with that? So we accept H0, not that we've written H0 formally, but we accept H0. And the result is not significant, or the result doesn't matter at the 5% level of significance. That's a fancy way of saying that we're 95% certain that this result doesn't matter. All right? Yes. Yeah, I'd be good at it.